Hello, everyone, and welcome to The Explainer. If you're looking to master the foundations of how we uncover new knowledge, you are absolutely in the right place. Today, we're going to look at knowledge as a physical structure. Think of it like a towering skyscraper of facts and data that we're about to build literally from the ground up. And to build that kind of structure, well, we need a blueprint. That blueprint is research methodology.
Okay, let's dive into this. When we look at massive engineering challenges, global health crises, or wild technological breakthroughs, we usually just see the final product, right? But how do we actually systematically uncover the truth behind those solutions? We don't just guess. We definitely don't just throw things at the wall to see what sticks. Instead, we follow a highly deliberate, highly structured path to go from a state of totally not knowing to a state of absolute, actionable certainty.
So here is our literal blueprint for today's explainer. We're going to move through 6 interconnected phases: the foundation of research, classifying types, the research process, qualities of good research, ethical rules, and finally, reasoning and data types.
Section 1. The foundation of research. Establishing the what and why.
As any good architect knows, you need a rock-solid foundation before you even think about pouring the concrete. Research is formally defined as a systematic investigation to gain new insights. Now, I really want to heavily emphasize that word, systematic. It's not just menial lab work or Googling a topic for 5 minutes. It's a deliberate, highly organized process of collecting and analyzing data. It is, quite literally, the powerful engine of human innovation.
And this brilliantly illustrates exactly why that systematic approach is so critical. It doesn't just generate knowledge or validate what we already think we know. It actually provides policymakers and engineers with the hard, undeniable facts they need for evidence-based decisions. It takes abstract, pie-in-the-sky ideas and builds tangible, real-world solutions out of them.
Section 2. Classifying research types. Tools for different jobs.
You know, a builder doesn't use a hammer for every single task, right? In the same way, researchers don't use the exact same approach for every problem. Now, what's really interesting about this slide is the clear evolution from abstract theory all the way to direct commercial value. Basic research explores universal theories in a lab setting. Think early quantum physics. Then, applied research turns that understanding into predictable technology. Finally, engineering R&D solves highly specific production problems, like figuring out how to build the actual microchips for a quantum computer. So the applicability shifts from those broad universal principles down to highly specific real-world situations.
Section 3. The research process. The step-by-step blueprint.
Okay, let's walk through the actual methodology. There are 5 macro phases to this blueprint. Step 1. Identify the problem and review existing literature. You have to know what's already been built before you can add to it. Step 2. Develop your research plan and methodology. Step 3. Roll up your sleeves and collect the data. Step 4. Analyze that data for hidden patterns. And finally, Step 5. Interpret and communicate the results. But remember, this is a dynamic, iterative cycle. Communicating your results almost always sparks entirely new questions, which sends you right back to Step 1 to constantly refine our understanding.
Section 4. Qualities of good research, building codes, and quality control.
Now, just because you followed the blueprint doesn't mean your building won't collapse under pressure. We need heavy, nuanced quality control. So the crucial point is this: without strict validity, meaning your research is actually measuring what it claims to measure, and reliability, meaning your results are perfectly repeatable, any data you collect is fundamentally useless. Without these strict building codes, the whole foundation just cracks.
Section 5. Ethical rules of research, the rules of the game.
We absolutely can't forget the human element here. These ethical guidelines are essentially the non-negotiable zoning laws that protect the community and maintain public trust in science. You must have informed consent from participants. They need to know exactly what they're signing up for. You must fiercely protect their privacy and confidentiality. You've got to minimize any potential physical or psychological harm. You have to operate with total, uncompromising transparency, absolutely no falsifying data to get the result you want. Whether it's responsible guidelines for animal testing or the honest dissemination of your findings, ethics ensure that our pursuit of knowledge never, ever comes at the expense of our humanity.
Section 6. Reasoning and data types. Selecting the right materials.
Let's move on and see how this all builds together. To fill in our blueprint, we need raw materials. Logically speaking, researchers employ 2 main types of reasoning. Inductive reasoning takes specific observations and builds them into a broader probability. You see a pattern and you formulate a hypothesis based on it. Deductive reasoning works in the exact opposite direction. It derives a specific certainty from an established general principle. The classic example goes like this. All humans are mortal. Socrates is a human. Therefore, Socrates is absolutely mortal. One explores probability, the other proves certainty.
And just as we have two types of logic, we essentially have two types of data to feed that logic. Qualitative data is descriptive. It's made up of words, narratives, interviews, and observations. It helps us understand the subjective richness of a situation, answering the how and the why. Quantitative data, on the flip side, is objective and mathematical. It's the numbers and statistics that give us extreme precision, answering how many or how much. The absolute best research often uses a mixed methods approach, beautifully combining the descriptive richness of qualitative data with the mathematical precision of quantitative data to paint a truly complete picture.
So, what does this all mean? Well, we've established the foundation, classified our tools, mapped out the process, ensured the quality, set our ethical boundaries, and selected our raw materials. Now that you possess this rigorous blueprint for creating true, reliable knowledge, what complex problem will you systematically solve next? The tools are literally in your hands. Thank you so much for joining me on this explainer today. Keep learning, keep building, and I'll catch you next time.